everybody. For this YouTube channel, I would like to talk about our LTspice 4. You can even go for LTspice 17. Um, first of all, you need to install your LTspice on your computer. You simply go to Google and type LTspice download free. The one that I pick up is this one, LTspice download. Well, let's talk about LTspice. This one we're going to do for the lab for my sophomore students or the second year student in electronics engineering. And that's help you to analyze circuits in the term of you can find your current flow in your circuit as well as your voltage at each node or each point in your circuits. It doesn't matter how complicated your circuit are. Okay, so this one is going to be a tutorial for LTspice. Let's start with the LTspice that I already installed on my computer. So I open up this one. Um, to get you to be familiar with LTspice, this is what you see. And you can see there are so many icons, on LTspice, and I use the LTspice 17. Now your icon is not really active yet. You can see the gray color here. You cannot do anything on these icons. But basically, it's work on the Microsoft Windows, so you can follow whatever you get used to working on your window. You can see here now there are only four main menu. You have File, you have View, you have Tools, you have Help. To get started, you need to start your new schematic, and it might have some library in here, but anyway, let's get started with the new schematic. See, you're going to have more manuals. You have Simulate, you have Tools, you have Window, you have Help, and now your icons, especially for your components, are active now. Let's see. If you want to go to start with drawing circuits, the simplest ones is that you have one voltage source and you have one resistor in series with your voltage source. And then you want to calculate for the current flowing through the circuit. What you can do is that you go to these the components. Okay, let's get started. Um, when you point your pointer on this icon, it's going to show you what it's about. For this one, it's going to be wired. That means you need an electric wire to connect different uh, components. And this one, a ground, you need that for your circuit. And this one is going to be labeled as the reference because sometimes you do a simulation and then you don't know, what the reference of the node is. So it's better for you to label your node. Can be either can be your A, B, C, or 1, 2, 3, etc. This one, resistor, and also this is very important because this includes many components, both analog and digital. Let's try to click on this one component. You can see. So you have op amps, you have digital Okay, let's try to click on digital here. Click open. You can see that there are so many uh, different gates. Here you have inverter, you have OR gate, you have AND gate. Here you have exclusive OR gate. What you want to place your components, you just click, for example, here you want to do exclusive OR, and then you click OK. That's going to be your what 5 input exclusive OR gate, and you can start from there. So we will talk about that later on. Okay, so this one, if you don't want it, you want to delete this component, what you can do, you can just go to scissor here, you can go to cut, okay, and you are left click, so it's gone, and right click, that's mean you are stop. And also you can use the menu or edit. They have our undo. You simply use the hotkey F9. You can even add text. And let's go through components first. You have resistor, capacitor, and the same thing just right here, icons for components. You can move your component. Okay, let's try, let's pick up our easy one. I pick up a capacitor here. So if you want to move, you can simply move your cursor over the device and left click, and now you can move the component around, and right click to stop. And what about our duplicate? F6. Duplicate is mean you want to copy. Since they have no command or control C, that's copy, right? And then control V, that's mean paste. Now you want to duplicate, you simply move your cursor and then left click and through the rectangular, around your device, and then you can move around. You left click, you can place, left click. Okay, I think this allow you only one copy. So you want to duplicate again. You move your cursor over your device, and then actually you don't need to do anything else. Just move around here. Okay, and this one even zoom out. If you want to copy, everything, you duplicate. So you draw a rectangle around your devices, and then you can in the term of copy and paste. So left click, that's mean you're going to paste your devices. And you want to undo, again, you go to F9, or simply go to menu, edit, and undo. So it's gone. And also, I'm not sure that for this one, you can even rotate, Control R, your device, and you can even do the mirror. For example, if you go to, let's pick up a resistor here, okay, you just move your mouse and go to the menu, edit, and now the rotate is going to active as well as your mirror. So you want to rotate your device. For this one is resistor. So you simply go to rotate. So that's Control R. Or let's try, you can even Control R on the keyboard. So let's move this one around. And you can also flip, just like mirror, or mirror. Uh, so you can flip your device, or simply Control E. Let's see. Control E is going to flip your device, back and forth. And to the right click, that's mean you stop editing And if I don't this one, I simply go to our scissor very quick and then left click on your mouse and it's gone. Okay, so that's the for example. And let's see another sub menu. You have a piece-wise analysis. We will use this so often. Now, this is the edit simulation command or the analysis modes. You have transient. That means you can see that you have a stop time. You have the time to start saving data. The maximum time step. That means for your x-axis, that's going to be for the time. So that's why they call it transient. And let's move to our AC analysis. Sorry, back to our transient in the case that you want to see your signal with respect to the time. You're going to use the transient. Now for AC analysis, uh, let's see, what you have to fill out is that a number of points, a start frequency, and a stop frequency. So that's mean you need to start frequency you can do for 0, and you can stop for 10 hertz or even 20k hertz or 20,000 hertz. So that's mean your x-axis is going to be your frequency in the unit of hertz, and that's good for you want to see the frequency response when the frequency change. How is your gain change? How is your voltage change? How is your phase change with the frequency? And you can even select type of sweep. You have a sorry, you have a different options. You can either go for octave. That means it's going to increase by 8, and decades, every 10 hertz. A linear, is become just like um, the same amount of step. That for linear. For if you want to start the frequency from 0 to 20,000 hertz, that's going to be beyond the limit in the term of your space on your LTspice. So you need to select a decade. That means you start from 1, and the next one is going to be 10 hertz, and the other one is going to be 100 hertz, and so on. An octave is increased by 8. So you have 1, and then become 8, and then become 16, and become 32. So that's octave. You probably get used to that already. Now DC sweep, in the case if you want to plot, that means your x-axis is going to be the DC voltage. You want to sweep the voltage, for example, the supply voltage from 0 to 20 volt. So you can do the DC sweep. Type of sweep, you want to do a linear. And start value, you can put like 0, and then stop value, you can put 20. And then increment is depend on you. You want to uh, more details or not about plotting. I can use like 1. So that's mean you start from 0 and become 1, and then 2, and then 3. You can even increase by 2. Okay, so that's uh, the meaning of increment. And now you go to noise. This they're concerned about your generate noise through your circuit and to do analyzation. This is transfer. You want to do look for some parameters. For example, the output resistance and your output that you need to put in. It can be anything. It can be a voltage, and it can be your the current. So we will see your examples later on. And this is operating point. This means just operate. For example, you have the simplest circuit with the supply voltage in series with one resistor, and you want to see the current flow in the circuit. You probably use this mode of analysis, and that's give you the current flow in the circuit. And you can even uh, show you the voltage at each point or each node. In the case that you have more complicated circuit, you have more uh, resistors, so you can find the current flowing through each resistor, and that's used the DC operating point. And you also know the voltage at each point. Okay, so this one you can get it from the main manual, edit, and LTspice analysis. And after you draw the circuit, you want to see your simulation. So you just go to simulate and run, or you simply use this icon, run. Okay, let's get started with the simplest circuit with one DC power supply and one resistor in series. And then what I'm going to do, I'm going to delete this one. Let's cut it out. Okay. Now you go to your component, and you look for okay, if you want to go back to the manual one. Sorry. um, let's see, it's still on digital. Okay, you can just use the upper arrow and you go to the voltage, click OK, and you have DC power supply. And also you can change this one if you right click, and for DC you can um, type in your DC value, can be 5 volt, 10 volts, and if you want another type of sorry, supply voltage in the term of AC, in the term of pulse, you just go to advanced. You can see it's have options for you to do a pulse, SI, signal, exponential, and this one I'm not sure. I'll get back to that later. This is probably about pulse. And for sinusoidal, they ask you to put the amplitude, of course, and the frequency, right? Here we go. DC offset, amplitude, frequency, time delay, theta, phi, and cycle. We will get back to this one later for more details. This one is just the basic tutorial for LTspice. Cancel. And then you want your R resistor, and you want this one to be arranged in horizontal. So you simply Control R, that's mean rotate. Left click to place and right click to stop. And you also need the ground for your circuit, otherwise it's going to give you an error. That's all you have. And then now you want to do the wiring between each component. So you go to wire, you left click again to change direction, and then left click to stop, and then you move, left click, change the direction, and then you're done. Now the next step is that you want to change the value of your R. Simply put your cursor over the component, and then you do the right click. Let's put this one as 10 ohms. Okay. You can even change the name of R1. Simply put your cursor over the label R1. Right click. You can change the label. And then for V1, I will put this one as the, let's say 24. Okay. And now by Ohm's law, V equal to IR, where V is the voltage, R is the current in unit of ampere, and then R resistance in the unit of ohms. So your current flowing through the circuit simply equal to V over R. That's mean 20 by 10 or 2 amps. Let's see what LTspice will give you. Next, you go to run. You ask you what type of analysis you're looking for. At this point, we will work on this operating point. So you click OK. You can see that it's already done. So you'll be in 001 actually is the supply voltage because it has only one supply voltage, V1, that's 20 volt. And then the current become negative 2 amps, okay? And also the current flowing through in the supply voltage that also become a negative 2. You're probably wondering why your current become negative. It's supposed to be positive, right? Well, this one concern about KCL and KVL, or Kirchhoff current law and Kirchhoff voltage law. For KCL, which means at each node, the uh, the total incoming current have to be equal to outgoing current of the node. And also the voltage, the KVL, Kirchhoff voltage law, states that the voltage, the source voltage, going to be equal to the voltage drop across each component. Okay, that's KCL and KVL. So by applying the KVL or KCL, Kirchhoff current law, that means you have an outgoing current and you have this coming incoming current have to be equal. So you add them up, have to be 0. That's why that's give you the current become negative 2 amp. Okay, so that for analyzing the circuit. Now, if you have more complicated, circuit, let's say you have one more resistor in series, so you cut this out, and then you add another resistor, that's R2, and you do the wiring. Okay, and oops, okay, let's move around once again. Oops. Okay, let's stop and let's move. You simply on the left click of the mouse, and then you can move this around. And then you need to do the wiring again to make the complete circuit or the closed circuit. Let's put R2 resistance become, okay, 10. Now you do the simulation. You can see that the problem is that when it shows VN001 and VN002, that's not clear for you. You have to look for where is the node N002, N001. What you can do, you can label each node in your circuit. So you simply locate your mouse over the line and you right click and you go to label net. Let's put this one as A. And you put the square under the letter A on your wire and you do the left click. Now you have labeled this node to be A. The same as on the right, you simply right click and left click to select this one and you type in the node B. Okay, and then you put the square on the wire, left click and right click to stop. Now what you can do, You do simulation. Clearly, you can see it easy to follow. This is your VA, that's 20, and VB, that 10 volt. So the voltage difference between A and B, or the voltage drop across R1, that's going to be 20 minus 10, right? That 10 watt. Oh, sorry, the voltage drop across your R1, that's going to be a 10 volt. So that's why you B, the voltage as B is the 10 volt. That's true. So the voltage drop across the R2 also are 10 volt. So 10 plus 10 become 20 volts. And that's equal to the supply voltage, which is the 20 volt. Okay? So this one I just show you the term of our labor net, or the network. Now let's move on. If you want to do DC sweep, or you want to plot, um, let's keep the circuit like this. I mean, if you want to do the plot um, for various supply voltage or V1, what you can do is that you need to go to Edit, and you go to your LTspice analysis, and you go to DC sweep. Okay, let's see. You need to fill up type of sweep. Let's say to do as the linear. This means the same amount of increment. Start value I'm going to put as 0, supply voltage, and I stop at 20 volt. Increment, I put just 1, from 0 become 1, from 1 then 2, from 2 and then 3. And you okay, missing sort. Oh, sorry. So the name of first source to sweep. So this one is the V1. So you type in V1, you click OK, and you simply left click, to place the command. And this explains that you want to do DC analysis, DC sweep, and your voltage source is V1, start from 0 to 20 volt, and the increment is 1 volt. Now you do a simulation, run. See, you're going to have the plot pop up and start from 0 to 20 volt. And now what you can do is that you want to add for the y-axis. Let's say you want to see the current, right, flowing into the circuit. In this case, they are series circuits. So you go to plot setting. You go to add trace, and you can also, I think it's somewhere around here. Here we go. Pick visible trace. You can just click on this icon, and you pick up, which one you want to plot. So you want the current flowing through R1 or the current flowing through R2, which is the same because this is in their series circuit. If you want to go back to your to your circuit, you simply go to draft, but you need to close, this window first. You go to draft, it's going to go back to your circuit drawing. And you want to go to plot, you just simply click this one, and you go to this icon, traces. Let's see, let's make plot I, R1, and V1. So you click OK. This is a surprise that you have the current become negative, this one 0, 0. And you expect this to be positive, right? Well, to do the correction, the easy way is you just put the negative side, and then you go to okay, to the circuit again, and then you go to edit, not edit, sorry. You go to the drop here, and you want to add trace. The other one is that you can kill this one by simply pick up scissor and then kill it, left click, and you go to icon here. So what you need to do is that you put IR1. I'm not sure that you can switch this one around. I mean, I want the current to be positive, right? Okay, let's try it again. Actually, they have yeah, enter the algebraic expression to plot. What you can do is that right click on this one, and you simply put the negative sign, and then you click OK. Now you have the current become a positive. Now, if you want to do the reading of the current at a various supply voltage, what you can do is that you need to get the readout. So you simply left click on negative IR1. You have a cursor 1 here. You can even add a cursor number 2. This is simply the XY coordinate. Horizontal is going to be what the unit of volt. This is the supply voltage. And for the vertical one, or Y coordinate, that's the current that's flowing through resistor R1. Where you can do the move around, you simply put the cursor over the line. You see the number 1 here, and then you left click. You can move your cursor around. Let's see, I want to do the reading at the supply voltage 6 volt. I simply move the cursor. You can even use the left arrow. Okay, and then go to 6. And you can see that you have 300 milliamps for the current flowing through R1. Okay. And you can also get another cursor too. Maybe do the right click. I'm not sure. Let's see. Cursor 1. I forget how to do that. That's help you to do to calculate for the slope. Okay. Let's see what I'm missing here. Cursor. Attach cursor first. Let's see here. Go to second. Click OK. You left click. You right click. Okay, 1 second. Okay, let's start again to do the plot. You go to run, and you have the plot, and you add your plot the current flowing through the resistor R1, and then you want to change this one to be positive. You simply put the negative sign before IR1, and now you want to do cursor. You simply right click on IR1 here, and you see attach cursor. You go for just first and second. You click OK. Now you have two cursor active here. You move for one. Okay, you can see this is the cursor number 1 and cursor number 2. And you can do the slope calculation, delta y divided by delta x, right? For the horizontal, that's give you the difference. This is delta x, and this is the delta y. So you'll be able to find the slope. Okay, that's all for now. So we will continue on the LTspice tutorial series 2.